Hello, in this video what I'm going to go through is solving literal equations and just some problem solving with linear equations. So in these first problems we are just going to be solving for a variable and then substituting in a value for an expression, and then we're going to go through a perimeter example, same kind of problem where we're just going to isolate a variable and then substitute some values in. Do that for a triangle, and then just some more substitution and evaluating. So finish out with a couple of story problems. And that looks like it's about it. So I'm just going to jump into this first problem. What we're going to do is solve this equation for m. So that means isolating m, getting m by itself, and then we're going to substitute a value of p and then crunch out the number and see what m is. So first off, in order to isolate m, I see that I'm multiplying it by 3 and then we're subtracting 2p. So what I'm going to do is add 2p to both sides first, and that's going to get rid of it here. So I now have 3m equals 15 plus 2p, and then what I can do is divide everything by 3, and that is going to isolate m. So I end up with an expression that says m equals, and then 15 divided by 3 is 5, and then I can write this as 2/3 times p. So that is the equation in terms of in terms of p, meaning m equals. So then what I can do is take this value of 6 and substitute that in for p. So 5 plus 2/3 of 6. So that ends up being 5 plus, and then there's a couple ways you can think about this. I can do 2 times 6, which is 12, and then divide by 3, and that's going to give me 4. I could have also said 6 divided by 3, which is 2, and then multiply that by the 2 on top, and that would also give me 4. And then when I add 5 to that, I get an m value at the very end of 9. So same thing here. In this case, m is being squared. So the first thing that we're going to do is still get rid of this 3p, very similar to what we did in the last problem. So I'm going to bring the 3p to the other side, and I get m squared equals 19 minus 3p. And now since m is being squared, to undo that, what I would do is square root both sides. So taking the square root, I get m equals, and that is equal to the square root of 19 minus 3p. And now I can substitute my value in. So m equals the square root of 19 minus 3 times that p value of -2. And then I get the square root of 19, and -3 times -2 is positive 6. That becomes the square root of 25. So then at the very end, m is equal to 5. Alright, so now kind of the application with this really is, now I'm given a perimeter formula, and it's just a perimeter of a rectangle. You would take 2 of the length and add 2 of the width and add those together, and that would give you the perimeter. What we want to do is solve this equation for w. So I've got the equation that says p equals 2l plus 2w, and our goal is to get the w by itself. So the first thing that I'm going to do is subtract 2l on both sides, and we can write this as p minus 2l is equal to 2w. And very similar to what we had done in the last problem is I can divide everything now. And when I do that, I now have w by itself. So I can now say w equals, because the w is isolated, instead of writing this as p over 2, I'm going to write it as 1/2 the p value, which is the perimeter, and then the 2's here do cancel. So that's going to become minus l. So that ends up being our equation in terms of w. So now it says determine the width of a rectangle, and I'm given the perimeter, so we're given the p value of 41, and I'm given the length of 12. So I end up with w equals 1/2 the perimeter, which is 41, minus, and then the length, which is 12. So the width is going to be equal to, and half of 41 is 20.5, and then bring down the minus 12. And then if I just subtract these values, I know 20 minus 12 is 8, so 20.5 minus 12 is going to be 8.5, and that is measured in meters. So again, if we would have done this the other way from the very beginning of this problem, what I could do with that perimeter equation, just to show you some of the work kind of going backwards, I could write the perimeter equation p equals 2l plus 2w. And if I substituted the 41 in for p, I would still have 2 times the 12 plus 2w. So you'll notice the first thing that I would do anyway is multiply this out and subtract it to the other side, and then we would end up dividing. So very similar to what we did before is by bringing this quantity to the left-hand side and then dividing by 2, I'm going to end up then with that same value. Oops, that was actually 17. Oops. There we go. All right. Next one. So similar, we have a triangle problem. So I have an area equals 1/2 base times height. So I've got the area of a triangle where B and H are your base and your height. I want to solve this equation for B. So equation equals 1/2. It's base times height. The first thing I'm going to do is actually get rid of the 1/2. And what I can do is divide by 1/2, which is also the same thing as multiplying both sides by 2. So I now have 2A is equal to B times H. And then if I want to get B by itself, I just have to divide both sides by H. So B is now by itself. And then I want to determine the base length. So I want to determine the B value of a triangle. And I'm given the area. So we're given the A value. So 2 times that value divided by the height of 3. And that ends up being 18 over 3, which is 6 centimeters. So kind of going back to some of the evaluating again. So we are going to solve each of these equations for y first, and then we're going to evaluate given the value of x. So again, very similar to what we did in the first problems. So what I'm going to do first is get the y by itself, and I'm going to do that in this case by subtracting 7x on both sides. So I have negative x times y is equal to negative 18 minus 7x. And then I'm going to divide everything by negative x. So what I end up with then is the y is now by itself. Negative 18 divided by negative x is positive 18 over positive x. And then I have another negative over negative, so this is going to be a positive. And 7x divided by x is just 7. So now that I have my y equation, I'm going to take this x value and substitute it in. So I get y equals 18 over that x value of negative 4 plus 7. 18 over 4, I know that 16 divided by 4 is 4. I know 20 divided by 4 is 5. So 18 divided by 4 is going to be right in the middle. And since it's a positive divided by a negative, I'm going to have negative 4.5. And then plus 7, which is positive 2.5. And that ends up being our value for y. Alright, so this problem is a little bit trickier. Reason being is because both of these terms have a y in common. So if I were to try to bring one of the expressions to the other side, I would still have a y then on both sides, which doesn't get us anywhere. So the fact that both expressions have a y, what I'm actually going to do is undistribute, and the word we use is factor, meaning I'm going to divide both of these expressions by y. So if I take 9y divided by y, I get 9, and if I take 6xy divided by y, I get 6x. So now the y is on the outside, and the y is being multiplied by the 9 plus 6x. So if I want to get the y by itself, all I have to do is divide both sides by 9 plus 6x. And this quantity goes away, and I now have y equals 30 over 9 plus 6x. So the y is now by itself, and I can substitute my value of x in. So I end up with 9 plus 6 times negative 6, and that gives me 30 over 9, and then that's minus 36. And that's going to give me 30 over, and then 9 minus 36 is negative 27. And then I can simplify this fraction. So that ends up being, if I divide both of these by 3, 30 divided by 3 is 10. 27 divided by 3 is 9, and then I'm going to stick the negative sign on the outside. So that's what the y value becomes. Alright, so just a couple of story problems. A jet flies an average speed of 540 miles per hour. How long will it take to fly from New York to Tokyo, which is a total distance of 6,760 miles? So in this problem, we're given a speed. So we know that the jet is flying at 540 miles per hour, and we are solving for how long it's going to take. So I want to know, I'm just going to, actually we'll use h for the number of hours that it's going to take. So if I look at in 1 hour, I would say that is 540 times 1. If it's 2 hours, I'd be doing 540 times 2, and so on. So in this case, I want to know how many of these hours is it going to take before I can get to a total of 6,760 miles. So what it ends up being is just a division problem, really. But again, the first part of that problem is really just figuring out what your variable is that you're going to use and how you're going to set up the equation. But really, I'm just going to take 6,760 and divide by 540. And that is going to give me a value then of 12.52 if I round up. And that would be measured in hours. So that is a very long flight. But again, kind of the goal of the problem is just to be able to set up that equation. Alright, so this next problem is a little more complicated. This next one talks about a car using a total of 16 gallons of gas, and it travels 460 miles. It's giving us the car's fuel efficiency on the highway, and then how much the car consumes in the city, and it's a little bit less. So we want to create and solve an equation to determine the total number of gallons that are used just on the highway. So this actually becomes a system of equations where I'm going to let x equal the number of gallons the car used on the highway. And I'm going to let y represent the number of gallons in the city. And what we know then is that it was a total of 16 gallons. So if I took all of whatever our number was for x and I added all the number we had for y, that would be 16. And now as far as the fuel efficiency goes, I know I'm getting 30 miles for every gallon used on the highway. So that's 30 times the number of x, plus we're getting 25 for the number in the city. And that number is going to be equal to 460 total miles. So it actually becomes a system of equations. To figure out how many we would use on the highway then would be a little bit of substitution. So we want to end up with x equals and then something. So what I can do first is rewrite this equation, and this is going to be kind of a longer problem. I'm going to rewrite this and get the y by itself. So y is equal to 16 minus the x value. And what we're going to do is a substitution. I'm going to take this quantity and substitute it in for y. So this is a review of system of equations where I can rewrite this bottom equation as 30x plus 25, and then instead of writing y, I'm going to write 16 minus x, and that is equal to 460. So I now have an equation that determines the number of gallons that were used on the highway. Which again took a lot of work just to get to this point, but we can solve by distributing first. So I would do 25 times 16 to get 400, and then subtract 25x, and that's just distributing, and that is equal to 460. From here I can combine my like terms. I have a total of 5x plus 400 equals 460, and then if I subtract 400 on both sides, I get 5x is equal to 60, and then when we divide, we get 12, and that is gallons. So 12 gallons of gas used then for the highway. Alright, suppose a runner has completed 7 miles in 56 minutes. Assuming that they keep the same pace, we want to know how long it's going to take them to complete an entire half marathon. So there's a couple ways of going about this. We could do a proportion, which would basically take our number of miles in a minute, and we could set that equal to the 13.1, and that would be measured in miles over the number of minutes that it would take. Meaning what I could do is take 7 miles over 56 minutes, and we could set that equal to 13.1 miles, which is the total, and then for how many minutes that is, I would put an x there. This is one way of going about this. The other way that I would look into it is to look at how fast they are actually traveling, how many minutes it is per 1 mile. So what we could do is look at 56 minutes divided by 7 miles, and that tells me that that person is running an average of 8 minutes per 1 mile. So then if we knew how fast they were running and we knew how many total miles they had, I could take that 8, which is minutes per mile, and multiply it by 13.1 miles. And that would give me then the total number of minutes that it would take, which ends up being 104.8. So it does say to express our answer in hours and minutes. So what I would first do is figure out how many hours that is total, and we know that 104 is past 60, so it's going to take over an hour. So what I could do is subtract 60 from that first. So I know that it's going to take over an hour, and if I subtract 60 from this, I get 44.8. So it's going to take 1 hour and about 44.8, or you could say 45 minutes. If I were to do it this way, notice I would end up taking 13.1, and if you cross multiply, which is how we solve a proportion, I would multiply that by 56 and divide by 7, and I would still end up with x being equal to 104.8. Alright, last one. We've got school, which is hanging 4 banners in their gym. It tells us the width of each banner and how long of a space we have for the wall. And in this diagram, it kind of shows you exactly where the banners will be placed, and then we've got all these spaces to fill, and we want to know that x value, so the space between them. So this is something you would have seen in geometry called the segment addition postulate, which says if I add each of these little segments, it gives me the length of the entire segment. So what I notice is I have 1, 2, 3, 4, 5 of these x values, and I am adding 4 of the banners, so 4 of the 8-foot banners, and that needs to be equal to the entire length of the wall then, which is 62 feet. So I get 5x plus 32 equals 62, and if we set this up correctly, I end up with an x value of 6. So that means the banners should be placed 6 feet apart.